RFID Batteryless Heart Rate Monitoring by Max Lucas, Will Ponder, Leah Salgado, Vanessa Seidel, Ericka, and Cecilia. We believe this is the next step in non-invasive patient care. Currently, invasive measures in collecting vitals can impede patient care. Less invasive methods tend to have better health outcomes. We've chosen to improve on wireless monitoring. Current designs in use are clunky and unreliable. Anything with a higher power need will eventually need a charge or a battery. We chose a low power version to avoid the need for button batteries or recharging. Even the sensor can be low power if the chip doesn't require much voltage. The sensor we're using is a piezoelectric sensor. It's very simple, just like the ones used in a guitar pickup or a microphone. It feeds a small voltage into the chip and then passes that voltage on through an antenna to a reader. On the other end, a reader will interpret that voltage. The way a piezoelectric sensor works is that some crystals have the capability to create an electric charge by receiving a mechanical stress. So when you bend a diaphragm made of one of these crystals, it'll actually create electricity. That electricity can be passed on through metal plates on either side of that crystal diaphragm, travel through electric leads, and be used for a different purpose somewhere else. The sensor we chose was actually a very simple one, and even with it not being very sensitive, it still produced about 300 millivolts. Most RFID tags have a very simple design. They have an antenna wrapped around the inside of the card, and they're connected to a chip that doesn't require very much power. So when the antenna comes in range of a reader, it harvests electricity from the reader and powers on the chip. The chip is then able to communicate with the reader and pass on either a signal or some kind of charge. We chose to use a WISP protocol for our RFID functionality. WISP is a ready-made protocol that allows you to add peripherals to an RFID chip so that you can take in data and process it. In our design, all the processing would be completed at the reader, so that the chip design itself can be very, very simple and only take in a charge, attach it to a timestamp, and pass that on through the antenna. In our original design, we meant to include an impinge speedway reader, but for simplicity, we used an SDR, which is a software-defined radio. All that does is take in a radio signal and then process it using a computer. That way, if we can see high and low voltages that correspond to the inputs on our sensor chip, then we know that the chip is working as intended. If you have any questions, please feel free to ask. We're happy to answer.